Hi, we're here today with Dan Kluche from Power Ecosystems, and today we're going to talk about combined heat and power, or otherwise known as CHP. Dan, tell us about CHP. Tell us what this concept's about.
Well, CHP stands for Combined Heat and Power, or also interchangeably used name is cogeneration. It's actually, for North America, sometimes considered currently a new technology, although it's really a technology that was invented by Thomas Edison. And in the early 80s throughout Europe and Asia, because of some innovations, particularly control technologies, it became such that you didn't have to have somebody monitoring a system full time. Mm-hmm. And so it became that you could run it 7x24 and it would really take care, for the most part, of itself.
So what do these run off? Generators, engines, boiler systems? How's the main system put together?
Well, the system is a reciprocating engine, and so again, it's very tried and proven technologies, and of course, as we know, with reciprocating engines or piston-based systems, we can use a lot of fuel types. We can use diesel, we can use biodiesel, we can use methanes, and what most commonly is used, because today it's the most economic, fastest payback, is natural gas.
Fantastic. Now, Dan's brought a model that we're going to have a quick look at now.
This is an actual scale model of the first water-cooled engine that they produced back in 1933. And that's really what makes the cogen side of things work, is that we have a piston-based engine that, rather than turning a drive shaft like your car, what it does is it turns a generator, generates electricity. Simultaneously to that, we're capturing the heat that comes off the engine, which is actually most of the energy that goes into the engine. And so on your car, that heat is expelled through the radiator, water-cooled, of course. And so we capture that heat as well as the heat through a heat exchanger that comes off the exhaust of the engine. And so what that allows us to do is that the engine can, simultaneously to producing electricity, be used to heat water for domestic hot water purposes or space heating, and it can be the lead boiler for buildings or many kinds of industrial or agricultural applications.
So this model you brought is a scale model of an engine from 1931. So what are the pieces that would be on here now at a modern engine? How does that differ? Well,
one thing you don't see on this, even though it's water-cooled, is really a very easy to see radiator, which, you know, today you would very much see a radiator. Also, the exhaust is just basically pouring out here, and normally what you would see is a tailpipe or an exhaust on a more modern engine.
And those are two of your key capture areas for heat on this. Dan, you work with a company called Energy out of the UK, and they are taking the CHP concepts and using biogas in agricultural operations to find efficiencies there. Can you tell us a little bit about some of the installations they've done, and then tell us a little bit more about how their concepts work into maybe Canadian agricultural situations?
Yeah, so what you end up with is the potential for a very strong positive feedback loop. Certainly you can use combined heat and power with natural gas, and there's many agricultural applications, whether it's chicken barns or dairy barns, etc., that require space heating and some domestic hot water heating and seed drying and many of these sorts of things. But for the optimized amount of heat usage, and also getting such that you actually wouldn't need to use natural gas, but you can actually end up in a place that you're self-sufficient on the farm, where you're actually using organic waste, you're pumping the heat from the engine into a digester of some sort. There's a number of flavors. And what that heat is allowing is that even in cold temperatures, we're keeping the organic or the anaerobic process underway, such that we're generating our own methane, and that methane will be used in the engine to produce more heat and electricity. And so just an absolute positive feedback loop.
And that's an interesting concept, because when you have your digestate in your batch digester, you want that even 37 degrees Celsius for that mesophilic digestive action in there. So this is fantastic that you're providing the same heat off what you're producing your electricity and your heat for to keep that powered. So that's a very compelling loop. That's a very compelling reason to use it.
Yeah, you end up with a fairly inexpensive source of gas, and you're able to produce that year-round because you have the heat source to do it.
Excellent. Now in Canada, especially in Alberta, where do you see the biggest opportunities for this kind of system to work? Not just with biogas, but with CHP as well. Where do you see it happening? Where's the benefit?
Well, the benefit, first and foremost, is the utility cost savings. You can reduce your utility costs on your farm or other buildings or other industrial processes 20 to 40%. You're also generating greenhouse gas credits, or it's green, even if you're running on natural gas, but all the greener if it's methane. Mm-hmm. And it's just because it's the most efficient way of generating electricity. You're using the heat, and obviously you're not using coal or other greenhouse gas emitters.
We chatted with Jim Hole, a major greenhouse operator in St. Albert, about how they use a CHP generator in their operations. Hi, I'm here today with Jim Hole, co-owner of the Enjoy Center in Edmonton. And Jim, you've put in a combined heat and power system to power the whole building as well as provide heat to it. And tell us a little bit about what your decision involved for going to that kind of unit.
Yeah, well, Rob, what we looked at was, of course, the eco side of things. We thought if we're ever going to build a new facility, we want to ensure that we're doing the right thing from the ecological perspective. And so that the combined heat and power system seemed like the right choice. It's natural gas fired. We can take the waste heat off of that unit, heat the greenhouse, use electricity for the facility. So it was a natural fit for us. And that unit just runs 24/7.
And how many kilowatts is it?
It'll kick off about 240 kilowatts. So that meets the vast majority of our power needs. We still pull some power off the grid, but we're running at about 70%, 80% of our electrical needs with the CHP system.
Excellent. And so far it's been running how many months?
We've had it in now for, it's getting close to a couple of years. So it's been up and running for a long time, so it just hums away.
Okay. And have you had any maintenance problems or any major issues with it?
Yeah, it's running very smoothly. There were probably a few communication problems early as far as the machine deciding to cut out at certain points there, but then we've kind of got that rectified, and it's been very smooth. The engine's reliable, and as long as I hear that thing churning away in the morning, I'm happy.